Hello. So in this, the fifth part of our talk on environmental health, I'd like to try to tie up some loose ends and bring in miscellaneous concepts that have to do with health issues. To get started, I want to say, how can we make sense of the worst toxicants? How can we categorize them? And I think this is very difficult to do. The general approach that we've had is to discuss a chemical when it becomes a problem. However, there are some generalizations that can be made. Earlier, we saw one such generalization in that PBTs, persistent, fat-soluble, synthetic chemicals, are more likely to become toxins than other chemicals for the reasons we discussed earlier. Things that mimic biologically active chemicals that are themselves biologically active are also likely to become a problem. So we have to develop sort of a taxonomy of those kinds of chemicals. And without being a chemist, I think that's very tough. Today, one of the things I want to do is talk to you about some of the classes of chemicals that have historically had problems so that you will recognize their names in the future when you hear about them. That said, there have been several initiatives by various organizations that are trying to monitor environmental toxicants and trying to reduce the exposure to these toxicants. And they often try to propose sensible classification schemes. Let me give you one example. The UN in 2001 sponsored a conference in Stockholm called the Stockholm Convention on persistent organic pollutants. They called them POPs. They identified the dirty dozen. These are chemicals that they considered the worst of the synthetic, persistent, organic, meaning carbon-based pollutants. And their intention was to eliminate or highly limit the production of these because their potential for damage to the environment and human health was so extreme. The dirty dozen include pesticides, and here are some of the names of them: aldrin, chlordane, DDT, dieldrin, endrin, heptachlor, hexachlorobenzene, mirex, and toxaphene. Industrial chemicals such as hexachlorobenzene, polychlorinated biphenyls, we've heard of the latter a few times already, and then byproducts of chemical synthesis, including hexachlorobenzene, dioxins, dibenzofurans, also sometimes just called furans, and also PCBs. The actual list of the dirty dozen is shown here: aldrin, chlordane, DDT, dieldrin, endrin, heptachlor, hexachlorobenzene, mirex, toxaphene, chlorinated biphenyls, polychlorinated dibenzopdioxins, and polychlorinated dibenzofurans. In 2017, the UN added 17 chemicals to the list, so this is an ongoing conversation. 179 countries have signed on agreeing that these chemicals should not be used. The US has signed on, but has not ratified the Stockholm Convention. The State Department official line is, "We currently lack the authority to implement all of its provisions." And what this means is that the US will not enforce the protections of the convention. And that is basically due to the US protecting large corporations that want to continue to profit by putting these incredibly toxic chemicals into the environment. So here is my review of the most dangerous classes of toxicants, and maybe some of this will stick with you. So first are the organochlorine pesticides. These are organic molecules that contain chlorine, and they include DDT, dieldrin, endrin, aldrin, toxaphene, mirex. Most of these are outlawed in the US at this point. Organobromines, including fire retardants such as PBDE that we learned about earlier in the movie, and there are two of those now listed by the Stockholm Convention. But organobromines are also biocides, which means they kill life, and they're also fumigants, which means they are used to kill various organisms, especially bacteria and fungi that might attack certain resources, such as seeds. Then there are organophosphates, which interestingly had their development as nerve gas in weapons of war, and then subsequently were used as pesticides because, as you can imagine, nerve agents are very effective pesticides. Next, we have the PCBs, the polychlorinated biphenyls. They are synthetic, they are stable, they resist decomposition at high temperature and pressure, and therefore they've been used in electrical equipment, in hydraulic fluids, and as plasticizers. There are dioxins. These are highly toxic. They're synthetic, and they're a byproduct of certain manufacturing processes, for example, herbicide production and paper bleaching. And these things are some of the most toxic chemicals ever known on Earth. In general, they're not purposely produced, but they are produced as a result of the organosynthesis of other industrial chemicals. Phthalates, which we discussed, including BPAs, this is a plasticizer with a track record of endocrine disruption, and that's just the tip of the iceberg on phthalates. And it's an interesting aside, phthalates are such a common contaminant of plastics that it is actually getting in the way of recycling plastics currently, because nobody wants to recycle plastics that have phthalates in them because it will contaminate recycled plastic. So there's an ironic disruption of a good idea, which is the recycling of plastics. And then finally we have PFAs, which we read the article about, are forever chemicals in our milk, and they stand for perfluoroalkyl and polyfluoroalkyl substances. And you should go back and read that article that we read for class now that you know so much about environmental toxicants. Now I want to cover a bunch of knockoff topics that I need to mention, and it's just sort of a laundry list of things to think about. The first thing is that human beings aren't normally exposed to single chemicals at a time, but are exposed to chemical mixture, and the effects are not necessarily additive. Let's see what I mean by that. Chemical mixtures can potentially interact by additivity. In other words, 1 unit of exposure to chemical 1 and 1 unit exposure of chemical 2 ends up causing 2 units of effect. That would be additive. But they could also interact synergistically. 1 unit of exposure to chemical 1 and 1 unit of exposure to chemical 2 could create more than 2 units of effect. And this is commonly what's seen with smoking. Smoking seems to enhance the toxicity of other toxins. And the third possibility is antagonism, which sounds bad but is actually good, where 1 unit of exposure to chemical 1 and 1 unit of exposure to chemical 2 results in less than 2 units of effect. So those are the ways that exposure to multiple chemicals can have an effect. And guess what? Synergy seems to be very common for toxicants, while antagonism seems to be rare. And here's the next guess what. Scientific studies of this are expensive, long-term, complex, and yes, very rarely done. Now, the second topic I want to bring in is the effect of toxicants on children. And if I were to ask you, how do children fare when exposed to toxicants, you probably could guess what I'm going to say next. Children are more susceptible to being affected by toxicant exposure. So why is that? Well, first of all, they weigh less than adults, right? So it takes a smaller absolute amount to affect them. Second, they have a higher effective exposure because they tend to play on floors and on the ground. They put things in their mouths more often than adults do, and therefore they get exposed more often to these things. A third thing about them is they're in active mitosis, which means their DNA is actively replicating. And therefore, exposure means that there could be more severe effects if DNA is affected, or if their immune system or their endocrine system is affected while young. It may have effects over the lifetime. And we're now starting to see with immune system suppression that the suppressed immune system can be possibly passed on. We've seen this in animal studies. As I said, exposure by children has many more dire consequences than exposure to toxicants of adults. And the exposure to adults has a lot of dire consequences. Let's move on. If we think about humans have interacted with pollution, historically, humans have lived by the motto, the solution to pollution is dilution. We just throw things out and we hope that the toxicant gets diluted in the environment so it doesn't affect us. We often call this the dilution paradigm. And it may have been okay when human activity was small and pre-industrial, so that human activity didn't impact global ecosystems. And I might want to say also that it may have been okay when humans weren't producing many synthetic chemicals, PBTs, POPs. The problem with this, I think you all would already know, is that there's no place to throw out trash because we live in one global ecosystem. And this reminds us of Commoner's second law. Everything must go somewhere. And if we put a toxin in the environment that persists, it might become a problem. And so the problem becomes worse with the usage of high quantities. And what is our economy these days about but the movement of huge amounts of material around the globe? And the problems become worse with persistent chemicals, with bioaccumulators, with mutagens, all the things that we've been seeing that environmental toxicants can be. And so we now realize that we actually live not by a dilution paradigm, but by a boomerang paradigm. I'll give you a second to figure out what that means. We call it the boomerang paradigm because what you throw away can come back and hurt you. And that's indeed what's happened. I just want to give you another example of one of the ways people first found out about the boomerang. From 1932 to 1968, a Japanese chemical company released methyl mercury into local waterways, thinking it would be diluted. Guess what? It wasn't. It bioaccumulated in shellfish and fish in the bay, and people ate that fish. And so they bioaccumulated the mercury, and soon, by later in life, they began to suffer from mercury poisoning. More than 1,000 people suffered from strange symptoms, many of which were neurological, dealing with the nervous system. And disease got its own name. It was named Chiso-Minamata disease. Chiso after the company, Minamata after the location. So this was one of the first times when this started to be noticed in the late 60s. Actually, it happened earlier than that, but it really became recognized for what it was in the late 60s, that we realized that what we threw away could come back and hurt us. Next, I want to talk about an exciting new field called ecotoxicology. And ecotoxicology is the study of contaminants in the biosphere and their harmful effects on biological organisms, especially at the population, the community, the ecosystem, and the biosphere levels. And since humans are part of the biosphere, it includes us, but it's much broader in scope than that. It takes into account what happens to the cohabitants of our planet as a result of the spread of toxicants in the environment. And the goal is to help policymakers determine the costs and benefits of industrial and technological advances. Currently, ecotoxicology is pitted as the enemy of progress or of economic growth, and that's a very quick way to shoot anything down. And I think we all have to learn how to counter that argument and be educated enough to realize, to say, is it really progress? Is the economic growth really worth it when people get sick, when animal populations go extinct, when you can't breathe the air, et cetera, et cetera? Finally, I want to talk about a philosophical idea of how we should organize our thinking about PBTs and other synthetic toxins. The precautionary principle states, once a new synthetic chemical is recognized to be potentially harmful, we should assume it is until proven otherwise. In other words, it's guilty until proven innocent. There is no reason we should accord chemicals the same protection we accord people in law of innocent until proven guilty. And by the way, it's fairly easy to look for potential harm. So we could pretty quickly look at a chemical and say, hey, this doesn't really have potential for great harm. Or we could say, yes, it does. This is the prudent way to proceed here, right? The prudent way to proceed is to identify chemicals as potentially harming and not develop them until we can show that they're not harmful. Chief objection, once again, is it will slow progress and limit economic growth. But I think you have to remember that new technologies rarely rescue an industry. The industry is not dying. It was already profitable beforehand. But what the new technologies do is they increase profitability. And as a result, they can be sold more cheaply, and consumers will utilize them, and therefore the lower price will increase demand, and you increase profitability that way. And that is sort of the way the economic system operates. And we have to say, it's worth it to slow that down and reduce profits and take our time and make sure something's not harmful. And I just want to point out that the effect of these new technologies is often to redistribute wealth to the already wealthy. We've seen this over and over in agriculture, where increases in productivity aren't necessary, but by selling a chemical product that increases productivity, what you do is some of the farm income comes to the people who generate that product, a large corporation, and away from the group of farmers as a collective. So, guilty until proven innocent. As we saw in the climate unit, corporations treat health effects of their products as a public relations campaign, or at best, a court case in which there's a winner and a loser. It's against their financial interest to find out that a chemical is harmful. They do not seek truth, but they seek victory. And I think that's important. Because they have that interest, they are not in a position to make sound decisions about what is good for society. Their economic incentive prevents their ability to make a good judgment. Why, as citizens, then, would we allow corporations to be involved in the decision-making about synthetic chemicals, as we do when we allow corporations to fund candidates? Why would we allow corporations to influence public opinion, as we do when we allow them to create think tanks or to create lobbying agencies where they have huge amounts of money to influence what people think, how legislators vote, and who gets elected? It kind of reminds me of the 1870s boss of the Democratic Party in New York City, Boss Tweed, who says, "I don't care who does the voting as long as I get to do the nominating." I think that's something as citizens we should all think about, how we have to act, what that means about our personal politics. Okay, to summarize this unit, it's true that health concerns differ depending on the level of economic development in a country. But all countries suffer from the exposure to synthetic toxins. They affect everyone everywhere, and as I say, they're in measurable levels in wildlife in the most remote regions of the globe, such as Antarctica. We know that since World War II, huge quantities of synthetic chemicals have been released into the environment, and they are implicated in the rising impact of environmental disease. It's very difficult scientifically to demonstrate a link between environmental toxins and disease. We need to take both a toxicological, a lab-based approach, and an epidemiological, a field-based approach. There have been many demonstrated cases of synthetic chemicals causing health problems and a lot of circumstantial evidence. And yet this remains an area where it's difficult to get funding. And it is essential, though, that this kind of research continue to be funded. And if you ever want to know why we need regulatory agencies, I would claim this is one of the reasons. We need to fund people who are going to do this research honestly and effectively. Now, we saw classic toxins, and that certain toxins either cause an effect above a threshold level or they don't. And they're not dangerous below that threshold level, and they don't build up. And exposure at one time doesn't affect the consequences at another time. But many toxins don't behave in the classic fashion, even though many apologists for the chemical industry would have you believe that they do. Instead, they cause disease at low-level exposure, especially if the exposure is over many years. And we've seen this with immune system modification and endocrine system disruption. These are two of the most common ways that chronic low-level exposure can be dangerous. Both immune system and endocrine system disease is increasing. In addition, we now see many toxicants are carcinogens. And I didn't even talk about many toxicants being mutagens as the larger category, and that some of those mutagens are carcinogens. But you can probably figure out what that means. And carcinogens cause the mutations that cause cancer. And they behave differently than a classic toxin because they have no safe level from a theoretical point of view. Any exposure could cause the mutation that causes cancer, even if that's a low-level probability or a very, very low-level probability. Overall, cancer incidence has increased dramatically and steadily since World War II, and it can't really be accounted for. And yet there's been relatively little formal study of this being due to environmental contamination. So this is an area where we should be focusing a huge amount of public dollars, and we should probably tax the corporations even more to get them to pay for these studies done by disinterested public servants who are scientists working at state and national health institutes that are protected from influence from large corporations. And finally, synthetic chemicals that show potential for causing environmental disease should be assumed to be dangerous until research shows that they are harmless. This is called the Precautionary Principle. So I hope this environmental health unit has really stimulated you to think about the health of human beings, but further, how we want to organize our society and how we want to organize the release of new synthetic chemicals into the environment. We all like the idea of modernization and progress, but this progress and modernization comes at a lot of costs. And one of these costs seems to be the declining health of many people. So that's it for this unit. We're actually going to have a supplement to this unit on environmental racism in a few days. But for now, I hope you found it stimulating, and I hope you talk about this with other people. And remember, until next time, study hard.